All right, hello students. Today we're moving on with lesson 21, writing and evaluating expressions using multiplication and addition. So on this one, we're going to kind of use multiplication and addition in our expressions. So we're going to kind of talk about how we work with them and kind of how we can develop them. So if we look at kind of the first model, it says the restaurant has square tables that servers can push together to accommodate, the customers. Only one chair fits along the side of each square table. So if we look here, here's our first square table. Only one chair fits on each side. Okay. Make a model for each situation to determine how many seats will fit around various rectangular tables. So here they give us quite a few models. This is 1 square, 2 square tables, 3 square, 4 square, and 5 square tables. And of course, they stop there. All right, so if we kind of look at this, very similar to kind of what we've done the last two times. They give us kind of part of it, and we want to fill out the other part. Well, if we have 1 square table, we have 1, 2, 3, 4 seats that could fit around it if we have 1 on each side of it. If we look at the the one that has 2 squares, well, there'll still be 1 here, 2, 3, 4, 5, and then 6. So we'd have 6. We go to the 4, we would have 1 here, 2, 3, 4, 5, 6, 7, 8. And hopefully you kind of start to notice a pattern here. Let's go do it one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And hopefully you notice here we're adding 2 seats each time we add a table. And so 5, should give us 12. Let's go ahead and count though. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 12. So yeah, that worked. All right, so if you notice here, since there were 5 here, we'd have 10 seats along each side plus 2 on each end. If we had 8 here, there's 4 seats on each side. That would be 8 plus 2 on each end. On 3 here, we had 3 on each side, so 2 sets of 3, and then plus 2 on each end. And the last one, kind of the same one thing with 2. 2 times 2 is 4, and then 2 on each side. So hopefully you kind of can see, as you can see, I'm skipping or kind of not talking about 50 and 200 yet. We can kind of develop our expression, because if I have t number of tables, I should be able to develop the number of seats. Well, the question is kind of what do we do? Well, if we, like I said, kind of as I was going through this, if we should notice, if I have 5 here, I have 2 sets of 5. I have a set of 5 up here, a set of 5 up here, plus I have 1 on each end, which is 2. If I had 4, I have a set of 4 down here and a second set of 4. That's 8. 2 times 4 is 8. And then I add 2, 1 for each side. If I have 3, I have 2 sets of 3. So 2 times 3 is 6. 3 and 3 is 6, plus 2 on each side. So what we should notice is that for t number of tables, we're going to first multiply it by 2, because that gives us kind of the 2 ends here. If we multiply by 2, it gives me this end and gives me this end. That gives me 10 if I'm talking about 5. I still need to get to 12, so I have to add 2 to each side, or add 2, because I need 1 on each side. So the same thing here, and see if it works for 4. Well, 2 times 4 is 8, right? Plus 2 is 10. Yeah, that worked. Worked for 6, or for 3. Yeah, 2 times 3, so t would be 3 in this case. 2 times 3 is 6, plus 2 is 8. And then, of course, it would work for 2 and for 1 as well. All right, so this is the expression we're going to use to kind of finish filling out this table. So for 50, it would be, if we're going to use 50 tables, it would be 2 times 50 plus 2. So like I said, kind of in the last one, this multiplication, this right here shows multiplication between 2 and 50. That gives me 100, and then 100 plus 2 is 102. So as you can see, I'm doubling it, and then I'm adding 2 to what I doubled. So let's do kind of the 200 without writing it out. So this, remember, 2 says to double the table. So if I double 200, that'd be 400, plus 2 would be 402. table. All right, so that's kind of our table with our expression. Let's go through kind of a few questions that they have for us. Are there any other ways of thinking about the solution to this problem? Well, I kind of did talk about that. I talked about doubling the number of tables and then adding 2. Another thing, I guess, that we could say or could think about is that regardless of the number of tables, there is 1 on each end. So no matter how many tables we have 1 on each end of the table set. And then 2 chairs on each side of the table. So that's kind of another way of thinking about it. I said double, but this is kind of another way of thinking about it. If I said regardless of the number of tables, there is 1 on each end, and each table has 2 chairs. I kind of talk about the other way. I talk about how first there's 1 on each end, and then each of the tables have 2 chairs that go with it, 1 on each side. So that's kind of another way of kind of thinking about it, but overall it should come up to the same answers. So the next one says, isn't it practical to make a model of 50 tables? So now we're going to kind of talk through what we did here, kind of step by step. So it's impractical to make a model of 50 tables. So it wouldn't make much sense to make a model of 50 tables. But if we did have a rectangle that long, how many chairs would fit on each along the sides? So this is just talking about along the side. Remember, each table has 2 chairs. So, would have 2 chairs. So if we had 50 tables on each side, we would have 50, and we'd multiply that by 2. Oops, not 5. I was putting 5 again. So if I had 50 tables, each table would have at least 2 chairs. So that'd be multiplied by 2 groups of 50. That would be 100 chairs along the side. Well, now it says how many chairs would fit on each end. So if we talked about it, at the end of each of these, there's 1 chair and 1 chair. That's 2 chairs. So how many chairs would fit on the end? That would be 2. So the next question, of course, would be how many are there all together? How many chairs would fit all together? Record it on your table. Well, we kind of already recorded it on our table. So then we just simply add those 2 together. We'd have the 100 that fit along the sides plus the 2 that are on one on each end. That would give us 102 chairs. Like I said, we already recorded that on the table, so we should be good there. And now the next part, kind of the same thing that we did for the 200, we did talk about, but now let's kind of write it out to see what we're talking about. If I had 200 tables, how many would there be on each side? Well, if I had, once again, 200 tables, I'm going to multiply this by 2. I'm going to write it just a little bit different so we get used to it, because there's 1 on each side, so there's 2 sides of the table. So that would give me 400 chairs. And on the ends, I still have 2, so I go ahead and I add 2, and that would give me my 402 chairs. All right, and the last part, like I said, this is something that we actually did. It says if we let T represent the number of square tables, square tables that make one long rectangular table, what is the expression that we would use? So once again, kind of reiterate what we talked about. We would take the 2 times the number of tables, so 2 times T, and we would add the 2 that would fit 1 on each end. Another way we actually could write this using the distributive property is 2 times T plus 1. All right, so that's our kind of first example we're going to talk about. We're going to go over one more example. So go ahead and stop the video and go ahead and move on to it. All right, hello students. Now we're going to move on to the next example. We're going to go over kind of a couple more tables and just kind of talk about how we would develop the expression. So let's go ahead and look at what's going on here. Let's say kind of look at it in your group. We're going to do this kind of all together. So determine the cost for various number of pizzas, and also determine the expression describes the cost of having P pizzas delivered. Excuse me. So it says Pizza Queen has a special offer on lunch pizzas, $4 for each. So remember, each word is a multiplication word. So for every one that we buy, we have to pay $4. They charge a $2 delivery charge regardless of how many pizzas we delivered. So for each pizza is going to cost us $4, but they're going to add $2 for delivery no matter how many we ordered. Okay, so let's kind of go through what we have. Determine the cost of the various number of pizzas, and also determine the expression that describes the cost of having P pizzas delivered. All right, so if we look at number 1 here, if we think about it, for one pizza, it's going to cost us $4 for the pizza, plus it's going to cost us $2 for delivery. We add that together, it's going to cost us $6 altogether. It does say cost in dollars, so we really don't have to put the dollar sign here because it refers to it right here, so it's okay. But now if I get 2 pizzas, well, now it's 2 times 4, remember, because for each pizza it costs $4, and then adding 2 for the delivery charge. So I got this because there's $4 for each pizza, so I have 2 of them, so 2 times 4 is 8. Plus they're going to charge me $2 for delivery, so I got to add 2 to it, and that would give me, what is that? If I add that together, I get 8, and that'll give me 10. And if I do that for another one, once again, if I have 3 pizzas, they're going to charge me $4 for each pizza. And I'm going to add 2 to it for the delivery charge, right? Every time they're going to charge me for delivery, no matter how many pizzas I have. 3 times 4 is 12, plus 2 is, was that 14? All right, so it went up by 4. So if you notice, each time they're going up by 4, because this is going up by 1. And if we kind of do one more, 4 times 4, because now I have 4 pizzas at $4 a piece, but they're still only going to charge me $2 because they don't care how many I buy. They just want to charge me $2 for the delivery. So now I have 4 times 4 is 16, plus 2 is 18. As you can see, pizzas went up by 4. The cost also went up by 4. Now it jumps from 4 to 10. Well, if we continue kind of with our expression, or with our expressions, if I have 10 pizzas times 4, and I'm going to add 2 to it, because once again, they don't care how many I buy. They're just going to add $2 for delivery. 10 times 4 is 40, plus 2 is 42. Well, using that expression so far, it looks pretty good. And the same thing with 50. If I went 50 times it, because 50 is the number of pizzas I have now, they charge me $4 per pizza, and I add to it $2 for delivery. If I did the multiplication, 5 times 4 is, I believe, 200, plus 2 is 202, excuse me. That's how much they'd cost. Well, if we kind of look at what we did, if we notice, the 4 here always stayed the same, the 2 here always stayed the same. The only thing that changed here was the number of pizzas, and that's where we get our P. This is where we get our variable from. So P changes. The number of pizzas that we ordered change, but everything else stays the same. This is where we get our expression. 4 times however many pizzas we buy, and then we're going to add 2 to it for our delivery charge. So once again, the word each means multiplication. They charge us $2 for delivery, and it says regardless of the number, so it doesn't matter. So this 2 doesn't change based on the number of pizzas. It's just kind of, it's called a constant. It stays the same. So this would be our expression. 4P, or 4 times P, we usually write it like this. The cost of the pizza times the number of pizzas plus $2 for delivery. If we answer the next question, what operations do we need to use to solve this? Well, we use the multiplication and addition. And of course, oops, I did spell that wrong. And of course, that's the name of the lesson, so that would make the most sense. Multiplication and addition. All right, so there we go. So we took care of the table. We took care of, and this is kind of how we developed the expression. If you like to do this on the side every time, that's perfectly fine. You might be able to see this expression a little bit easier, especially when we have multiple operations going on. All right, if we're going to do one more, let's go ahead and kind of look at one more kind of exercise or one more example. It says, if the pizza price rises to $5 and delivery price to $3, create a table that would show the total price of delivering 1, 2, 3, 4, 5 pizzas. Include the expression described. Well, everything pretty much, so if we kind of come down here, if we remember from the previous example, we had 4 times P plus 2, right? Well, now they're going to change it. Instead of $4 a pizza, they're going to charge $5. So all it's going to change is the $4 is going to change to 5. The pizzas are going to stay the same. And now they're changing the delivery price from $2 to $3. So now instead of adding 2, we're going to add 3 each time. So you see, I'm kind of working backwards. There's nothing wrong with doing this because I already have this information from my previous table. So I take my previous expression and I made the changes. So the pizza price went up to 5, delivery charge went up to 3. And now I want you to go and pause the video. I want you to try to fill out the rest of these. All right, so hopefully you paused the video and gave these a try. I'm going to go ahead and kind of write out the first one. So $5 times the 1 pizza plus the delivery charge of 3. Right, now we can multiply it. 5 times 1 is 5 plus 3 is 8, so this would be $8. Now once again, we don't need the dollar sign in here because it tells us that the cost is in dollars. Now if I did it again, now it'd be, instead of 1 here, it'd be 2. So 5 times 2 is 10 because I'm delivering 2 pizzas. 5 times 2 is 10 plus 3 would be 13. If I did it for 3 now, remember I'm multiplying this by 3. Number of pizzas times 5, 3 times 5 is 15 plus 3 is 18. I did it again, that would be 4 times 5 is 20 plus 3 is 23. And the last one, 5 times 5 is 25. So remember, number of pizzas right here is my P. 5 times 5 is 25 plus 3 is 28. All right, so there you go. That's what we did. That's how we'd actually even make a change if we needed to. The variable would stay the same. The cost change based on the new information provided. All right, so go ahead and stop the video and go and move on. If you have a question, please raise your hand so I can come by and clarify for you.